Hello everybody and welcome back. In this episode we are going to add a rigid body class to our physics simulation, but of course we're not going to use it now, we're going to use it in the next episode. Yeah, first of all I want to change some things in the simulation class. Last time we added our algorithms to push polygons and circles apart from each other. And what I wanted to try now is that we can see our collision manifold information. And for this, I'm gonna change something in the code right here. First of all, I'm gonna command these move statements here. And I wanna change this call here to set it to the result. And then we should see our manifold information. So let's refresh, and there we go. Now we can see what actual information is stored in our collision manifold. All right. Cool. Now for our rigid body class. First of all, I want to just comment everything here. We don't need it now, because I mean I think we're gonna change this one in the next episode. Yeah. Anyways, let's go and create a rigid body class. Here I already created a rigid body JS file. Just press here on the new file, create a rigid body JS file, and then yeah, then we can create the rigid body class. So call it rigid body. Oh, did I forget something? No. All right. Then we have a constructor. And here, oh, 1 second though. And here we're gonna pass a shape and a mass. Okay, and we're gonna assign shape to the shape for the rigid body. The same with the mass. Note that the mass can also be density. I think that's a more often used approach to use intensity instead of mass. You can calculate the mass then using the area of the shape. I think we calculated the area some episodes ago when we did the calculation of the centroid. That must be, where was it? I think it's in the math helper class. Right here, the A. Yeah, right. Here's the calculation for the area. I think you can just use this one with the density, and then you can calculate the actual mass of the rigid body. Okay, but for simplicity reasons, I'm going to use the mass, just simply, yeah. Here I'm going to call a if statement, or I'm going to write a if statement, and we're going to check for we're going to check if the mass is greater than 0. If it is, we can calculate the invert mass. This is just 1 divided by the mass. And the invert mass is handy to calculate, because we will save divisions if we have that already in our if we have that stored already in our rigid body class. So that's quite handy, but we need to make sure that mass isn't 0, because of course we can't divide by 0, and if it's negative, well, we don't want to have that. So we're gonna set it to 0 then. Okay, and then we have a force accumulator. This will be a vector, new vector 2. And this vector we're going to use to simply add any force we want to add to the rigid body, like gravity, for example, or if there's a wind force, for example, then we can add this simply to the force accumulator and use this. Yeah. And then, of course, we have a velocity. This will be also a vector. Also, we're going to set it to 0. And that's it for the constructor. Okay. Of course, yeah, I forgot. If the mass is equal to 0 or negative, we're going to set this dot mass to 0 and this dot invert mass also to 0. Okay, then we can add some methods. First one will be add force. Yeah, this will have the parameter force, and we're gonna add this force to the force accumulator. Force, there we go. Then we have a add velocity method. It will also have a velocity parameter. And we're gonna add this velocity, well, to the velocity of the rigid body. Okay. Then we will have a set velocity method. And here we're gonna set the velocity, but I'm gonna use the copy function here because I don't want to set this velocity to a new reference. This will probably, this will prevent some buggy behavior, because if the velocity here changes, the velocity of the body will also change, and we don't want that. We just want to have the values of the vector, not the vector itself, not the reference. Okay, and then I'm gonna add the update function. This will have a delta time. And here I'm gonna call this dot integrate with the delta time. And then of course I need to add the integrate method too. This will be delta time, and there we go. In the integrate method we are calculating, or we are converting the force from the force accumulator to a acceleration. Then we convert the acceleration to a velocity, and then we're gonna convert the velocity to a move in the position. And I think that's everything for this episode. In the next episode, I'm gonna change the simulation class here, that our simulation works with the rigid bodies we created now, instead of just shapes. All right. Then, I guess, see you in the next one. Bye.